Hello, everybody. Welcome to session 4. So we are done with session 1, 2, and 3, where I've explained you all about hydrology, importance, its applications, global water distribution, forms of precipitation, such as rain, snow, sleet, glaze, hail, fog, mist, etc. And then types of precipitation, such as cyclonic precipitation, orographic precipitation, and convective precipitation. So in the last session, I explained once we receive the precipitation, how it is measured using the instrument rain gauge and different types of rain gauge, that is recording rain gauge and non-recording rain gauge. So once measurement is over, how do we measure the average precipitation using arithmetic mean method, polygon method, that is Thiessen's polygon method, and isohydral method. So all these were explained in the last session. So once measurement is over, we need to present it. So presentation of rainfall data will be explained to y'all in this session. Okay, fine. Presentation of rainfall data. So the first method we present is the mass curve of rainfall. So this is a simple curve which can be arrived at when we plot the accumulated precipitation against time. So the mass curve of rainfall, it is a plot of the accumulated precipitation against the time, which is plotted in a chronological order. That is old to new chronological order. Always the latest will be now. So this is called as chronological order. So in an increasing way from the old year to the new year. So that is called as chronological order. So the records of flow type, weighing bucket type, tipping bucket type, that is recording rain gauges, are used in this form. So the mass curve of rainfall are very useful in extracting the information on the duration as well as magnitude of a storm. So here we'll come to know the duration as well as its magnitude. And intensities at various time intervals are also obtained when we draw the curve, and when we draw the slope of that curve. When we do that, we will come to know the intensity of particular storm. For non-recording rain gauges, mass curves are prepared from the knowledge of the approximate beginning and end of the storm, and by using the mass curve of adjacent recording gauge stations as the guide. Because in non-recording rain gauges, a person goes and collects. So approximate beginning and end has to be taken there and it will be drawn. But in recording, since it records automatically, that end of the storm and starting of the storm will be recorded automatically, and easily we can plot the graph and we will arrive at that mass curve where the slope gives us the intensity of rainfall. So you can see the figure here. A typical mass curve of rainfall at a station during a storm is shown in given below. So here the time in days: first day, second day, third day, fourth day. Okay, what is the amount of accumulated precipitation? So during the first hour, or during the first 20 minutes or 40 minutes, or the first hour, if it is 4 centimeter, it will be plotted. Then second hour, third hour. In this way, at different hours, it is plotted, and then it is joined by a smooth curve, where this curve is known as mass curve of rainfall. So the first storm where it increases and where there is nothing, you can see here. This is the time period where it is a straight line. So here it shows that there is no storm occurred. So during the first storm, all the accumulated rainfall or that precipitation is added up and gives up to 10 centimeter. Then during this period, since it's a straight line, so the rain had stopped, there was no precipitation. Then again the curve started increasing. There was a second storm, that means, okay, second part of rainfall. Again, when we add up that, we get 4 centimeter. So in this way, this curve is plotted and we will come to know the duration and the exact accumulation of the rainfall. The next presentation of rainfall is by hydrograph. Hydrograph is a plot of intensity of rainfall against the time interval. So hydrograph is derived from the mass curve and is usually represented as a bar chart. So in mass curve, we joined it with a simple curve, but here bars are used. So it's a bar chart. It is very convenient way of representing the characteristics of a storm and is particularly important in the development of design storms you can predict extreme floods. Okay, the area under a hydrograph, it represents the total volume of rainfall which is received in that particular period. The time interval used depends on the purpose, whether it is urban drainage problem, where small durations are used, while flood flow computations in larger for catchments, the intervals will be about 6 hours. So this is a typical hydrograph which is drawn. So for example, the time is on the x-axis and the rainfall intensity in per hour will be, so it's a plot of intensity against time. Okay, not accumulated rainfall against time. For the mass curve, it is accumulated rainfall against time, but for hydrograph, it is rainfall intensity against time. So time will be on the x-axis and intensity on the y-axis. It is per hour or centimeter per hour. Then for the first 10 minutes, when we know it is 0.8, it will be drawn with a straight line. It is joined with a straight line. Again, this line is extended. Next one up till 0.8 for 20th minute. So again, this will be connected with a straight line and down to this 10. In this way, this bar chart gives the presentation of rainfall, and that is known as a hydrograph. Moving on to the third method, it is moving average curve method. So in this particular method, it is similar to mass curve, but here directly accumulated rainfall is not taken, but average is taken. So the graphical representation of rainfall in any of the above methods will not show any trend of cyclic pattern in that data. So the moving average curve, it smoothens out. So we get a smooth curve where variations, it will have certain extreme variations and it indicates the trend or cyclic pattern if any more clearly. It is also known as moving mean curve method. So how do we do this? The procedure to construct the moving average curve is as follows. The moving average curve is constructed with a moving period m per year, where m is generally taken 3 to 5 years. Let x1, x2, x3 up till xn be the sequence of given annual precipitation or rainfall in chronological order. Yi will denote the ordinate. So ordinate is going to be determined by moving average curve for the ith year. So m is equal to e 3, where yi is computed from like for particular year 92, 93, 94. So if we take 93, the precipitation of 92 plus 93 plus 94 divided by 3 will give us the average, and that values are going to be taken. For example, y2 x1 plus x2 plus x3 is equal, divide by 3 will be y2. Okay, y3, it is previous x2 plus x3 plus x4. Y4, what will happen? Y x3 plus x4 plus x5. So previous year, next year, and that present year will come in the between. So previous year is added and the consecutive year is added. So x1 plus x2, x plus 3. This is the precipitation of previous year, present year, and the next year, and they'll be divided by 3. And we will arrive at y2, y3 up till yn or yi, yn minus 1. And finally, we can determine the precipitation using this formula. Yn minus 1 is equal to xn minus 2 plus xn minus 1 plus xn divided by 3. So this moving average method gives us a smooth curve where we can present the rainfall data in this manner. So from the above equations, the computed value of I corresponds to time, the middle value of x being average, and therefore it is convenient to use odd values of m. Okay, next we have to determine the precipitation where some data is missing. So that is known as estimation of missing precipitation record. So a sufficiently long precipitation record is required for frequency analysis of rainfall data. So we need for n number of years the precipitation data at n number of rain gauge stations. But sometimes they can be some sudden unnatural cause where certain rain gauge may not operate. But a particular rain gauge may not be operative for some time due to many reasons. It becomes necessary to estimate that missing record and fill the gap rather than to leave it empty. This is done by the following methods. interpolation from isohydral method. Second one is station year method. Third one is arithmetic average method. And the fourth one is normal ratio method. So I'll just explain in brief about these three methods, but for your syllabus, you have normal ratio method. So what happens? Sometimes there can be a reason where some data is missing. Some rain gauge has not been operative in that particular year due to some problem, some error, some natural calamity. That time, this data will be missed. So we need to fill that gap by knowing the other records, other values, we can arrive at that. So simple interpolation from isohydral method. So where isohydrates will be joining the points of equal rainfall or magnitude of equal rainfall. So when record is missing at that particular station, the interpolation techniques are used and the missing record is worked out. The factors like storm factor, topography, nearness to sea are considered for proper estimation. Next one is station year method. In this method, the records of two or more stations are combined into one long record, provided the station records are independent and the areas in which stations located are climatologically the same. So you cannot take one in a desert, another one in some western area where there is heavy rainfall. So the climatologically, the weather, the temperature, everything has to be rain. Then only we can go in for this station year method, and then the missing record can be computed in that particular year by finding the ratio of averages or by graphical comparison. And the third one is simple method, that is arithmetic mean method. Here also it is arithmetic average method. So here it is number of other rain gauge station recording, the surrounding station in question, which is missing record, is required. The missing rainfall record at the station is taken as average. Then which is even compared with the available data surrounding the station P1, P2, P3 up till Pn. Then these are compared with that station surrounding a non-operative station X. And finally, the rainfall at X is given by P1 plus P2 plus P3 up till Pn divided by 3. So this method is applicable when normal annual rainfall at various stations up till X does not differ by more than 10% without the surrounding station. Then we can go in for this average determination by arithmetic mean method. And the last method, or the important method, which is there for your syllabus, is the normal ratio method. So this method is applicable when normal annual rainfall at required station differ more than 10% of annual rainfall at surrounding station. So we need to find out the normal annual rainfall. We have to find whether it differs more than 10% or less than 10%. If it is less than 10%, then we go in for arithmetic average method. If it is more than 10%, then we go in for normal ratio method, where we say P1, P2, P3 till Pn are the rainfall records or precipitation values at n stations during a particular storm surrounding the station X, and N1, N2, N3 are the normal rainfall values, annual normal rainfall values for n stations. And let us assume that NX be annual rainfall for station X, but PX is missing. Okay, so the rainfall at station X during a given storm is missing. PX is missing. So how PX is calculated is PX is equal to 1 by N, NX by N1, P1 plus NX by N2, P2 up till NX, NXPN is given and finally determined where the station X has a missing precipitation record. In this way, we calculate the missing record and we estimate depending on other known values. And finally, the missing data, which will have created a gap, is filled by either interpolation method, either by averaging method, or by graphical method, or by using this normal ratio method, where the difference is more than 10% of the annual rainfall values. N1, N2, N3 are the rainfall values. P1, P2, P3 are the precipitation values at a particular station X, where Px for a certain year will be missing, and hence we can determine easily using this formula. So in this way, the various methods are used to find out the estimation of missing precipitation value. That's all for this session. Thank you.